Okay, let's look at some proofs of this proposition. Here's the proposition we want to prove, and we can use this fact. We don't have to, but we can. So I'm going to look at part A here. It says, given L, M, X, Y are integers, where L is congruent to X mod n, and M is congruent to Y mod n, then L plus M is congruent to X plus Y mod n. Okay. Now I want to show you that this is a little bit different from here, because here you have L plus M are integers, but A and B are remainders. So A and B are in Zn. The other difference is that this is a circle plus and not a plus. So one of the hints was that you could use proposition 3.4.4 twice. You don't have to. Well, let's go and look through some of the solutions that were handed in and see what we can, let me make a critique, and you'll see what I accept and what I don't. Well, before I do, let's just think about this problem a little bit. Now, like I said, you don't have to use proposition 3.4.4, but suppose we do. Suppose we used proposition 3.4.4 twice. So let's just write down basic idea. Oops, sorry, something happened. All right, here, let's do something here. Sorry, give me a second. All right, now if we're going to use it twice, and you look at how proposition 3.4.4 works, we probably want to apply it on the left-hand side and on the right-hand side. All right. So if we apply it on the left-hand side, we would have mod L plus M n is equal to A plus B. But let me just write in what A and B are. This is mod Ln plus mod Mn. Okay, so that's 3.4.4. Okay. All right, and then on the other side, if we were going to use it on x and y, we'd say mod of x plus y n equals mod xn plus mod ym. Okay, so that's also 3.4.4a. Okay, so I've used 3.4.4a twice. Now, what can I do with this? Well, what's the information that's given me? Here it says L is congruent to X mod n. What does that mean? That means that their remainders are equal. So in other words, mod Ln and mod Xn must be equal, since they're congruent. On the other hand, if M and Y are congruent mod n, then their remainders are also equal. So that means that mod Mn and mod Yn are also equal. Not equivalent, but equal, right? If two numbers are equivalent mod n, the remainders are equal. So these two are equal, these two are equal. That means that these two expressions are equal. That means that these two are equal. That means that x plus y and L plus m have the same remainder, which means that x plus y is congruent to L plus m. So let me write that out. I can say that mod Ln is equal to mod Xn, since, I'm just going to write out those ideas, since L is congruent to X mod n. And then I also have mod of Mn is equal to, and remember, see, I'm putting equals here, which is correct, equals mod Yn, since M is congruent to Y mod n. Okay. All right, so that tells me that, so mod Ln plus mod Mn is equal to mod Xn plus mod Yn. And all this is, I'm just substituting, right? That I can just say that's substitution. Okay. All right, so that means that that's telling me that mod L plus M n equals mod y plus x plus y n. And that's also substitution, right? Because this is equal to mod L plus Mn, and this is also equal to mod x plus yn. So this is also equal to substitution. Okay. And that means that L plus M is congruent to x plus y mod n, and that's the definition of modular equivalence. Okay. So I have my reasons here. I put all my reasons in boxes. I'll put my reason box here, my reason box here. Now this is pretty much a proof. I mean, the way I said it was I used my write-down statements and gave my reasons. So this is pretty much a proof. I should probably rewrite it to make it nicer. So let's see what people did, and let me give my critique. All right, now what did this person do? Here he wrote the statement, or she wrote the statement, and let's see what we did here. So here's this. Here's the. These are the two givens. That's fine. And then, so where does he go from here? Where does she go from here? So since L is congruent to x mod n, L equals nk plus x. All right, this is very good, right? This is basic definition of modular equivalence. This is the other definition of modular equivalence. And then here also we have m and y differ by a multiple of n. So that's very good. All right. Then we have substitution, and then did some algebra, and then we got L plus m equals some multiple of n plus x plus y. So that means that the L plus m and x plus y differ by a multiple of n, so they're congruent. So this one's very good, very logical. Used a different method. Don't have to use the method that I suggest. This one is just fine. All right, let's go on to the next one. All right, so here's the question. L plus m equals x plus y mod n. Wrote it in green, so that made it clear to me that this is what you're trying to prove. That's good. And then here you just wrote down the hint again. So this one does not really rate as a proof. I don't see anything here that proves anything. So I think someone just didn't finish here. So let's go on to the next one. I don't even know if I can read this. Okay, so let me see if I can follow this proof here. All right, this is the given, L plus m. Well, no, this is not the given. This is what you want to show. So what's going on here, I don't know. Is this part of the proof? Is this a restatement? I really don't know. Now this is the given here. And then here again is what you want to prove. And then here's a statement that's not true. It's not true that L plus m is congruent to, well, let's see. It is actually true that L plus m is congruent to this modulus here, but I don't see what's going on here to make this work. But the basic problem I have with this proof is that you started with what you want to prove, and I just am not. If you do that, then I'm really not sure where you're going. I mean, at this point, I'm just kind of, because things are so unclear, I'm just going to kind of say this is not going to work. So you go on to the next one. Okay, let's see what this one says. Now here's another proof that went back to the other definition of modular equivalence, which is very good. Here you have L equivalent to x mod n, m equivalent to y mod n, and here they wrote what that means, and then they did the algebra, and then they wrote what it means. So this one I like. It's very, very clear, very straightforward. So I like that one. All right, now this one is a nice start. So here we have the givens, and then here we have this assertion that mod L plus mn equals x circle plus y. Unfortunately, this is not true because x and y are not necessarily remainders. X and y are integers. So you can only define circle plus on remainders. So the proof kind of breaks down at the second step here. All right, now this one here is interesting. Here it didn't restate the proposition, but here they said mod ln equal a, mod xn equal a. No, that's true because L and X are equivalent mod n, but it didn't really give a reason here why you can set those both equal to a. And mod mn equal b, mod yn equal b, that's also true, but didn't really give a reason. You can't say that's because of proposition 3.4.4. It's because L and X are equivalent mod n, and m and y are equivalent mod n. So that's true. Then here the person wrote what you want to prove. Okay, so right away my red flag is up that you can't do that. You can't get to what you want to prove until the very end. All right, and then here from there they took the other definition of modular equivalence that mod L plus m n equals mod x plus y n. So it's true from this that this is true because if two numbers are equivalent mod n, their remainders are equal mod n. And then actually here is where they used proposition 3.4.4. So the ideas are all here, but they're in very wrong order. You need to start from this should be at the end, not at the beginning. And I'm not sure how to read this. I'm not sure if I start here and then go to the left, or I suspect now that I start here and I'm supposed to go down and all of this is supposed to go into this. So it's just very hard to figure out which direction to read this. So that's probably good for half credit. All right, so let's look at this one. So here we have given L, M, X, Y, and Z, where L is in X, L is equivalent to X mod N, and M is equivalent to Y mod N. This is very good. Then this is what you want to prove. All right. So if I'm looking at this as a proof, I'm saying, well, what's going on here? You've already asserted what you want to prove. How are you going to prove it if you've already asserted what you want to prove? All right. So that's one strike against this proof. The other strike against this proof is the use of X parenthesis mod N. This doesn't mean anything. I'm not sure if they mean the remainder of X mod N. The way we write the remainder of X mod N is mod parenthesis X comma N. So this notation doesn't mean anything. You might have seen this notation in other classes, but as the book says, we don't use this notation, so I just don't recognize what this means. All right, now here's an example of a proof that would have been good if it were rewritten. All right, so let's start with this example. So here it says, so they're assuming the statement of the theorem, of the proposition rather, and then they're defining variables a and b. That's good. And then you say, so mod L plus mn equals a circle plus b. How do you know that? What's the justification? In fact, that's proposition 3.4.4. This is true, but where's the justification? All right. Then here we have a equals mod xn and b equals mod yn. Now it's true that you can set a equal to mod ln and a equal to mod xn, but you need to justify that. The reason that you can set a equal to both of these is that L is congruent to x mod n. None of that's mentioned. All right, now here we go again. It says, so by proposition 3.4.4, mod L plus mn equals a plus b. Now, here we just repeated what goes up here with the justification. So if they had crossed this out, that would have been good. Okay. Then here it just says mod x comma n circle plus mod y comma n. Equal to what? I don't know. This is just an assertion. It's not an equation, and it's an expression. I don't know what this means. Right. Now here then you write mod x plus y comma n equals mod x comma n circle plus mod y comma n. That's true. Why? Well, that's true by proposition 3.4.4. But I don't know if the by proposition 3.4.4 refers to this up here or this down here. I really can't tell. Now, if they put by proposition 3.4.4 over here, I would know. Okay. All right, and then here this comes, but I don't see how this follows. I don't see how it follows. In fact, the reason why it follows is that you can make this is also A and this is also B. That's true, but the connection is not made there. So there's kind of like shadowboxing. The punches aren't landing, but there's a lot of. But I mean, you're getting somewhere, and if you put the connectivity tissue in correctly, you'd have a structure here. But as it stands, there's nothing connecting steps to each other. All right, so let's take a look at this one. Here we have mod ln equal A, mod mn equal B. That's good. You're defining your variables. And then here we say let mod xn equal A. Now, how do you know that you can set mod xn and mod ln to be the same thing? You need to justify that. You can do that only because L and X are equivalent mod n. You need to say why you can do this. You can't just, that's not, in general, for any L and X, you can't, any arbitrary L and X, you can't just do that. You need to justify that. All right, let's look down here. L plus M equals mod L plus M comma n. That's certainly not true. All right. I don't know if that's supposed to be an equal or a congruence. If it's a congruence, then that's true. And then here you have congruent to x plus y mod n. Now, if that were true, if you could conclude that right away, then you'd be done at this point because you'd have L plus M is congruent to x plus y. So, and there wouldn't be anything more to prove. Now, it looks like they're trying to go backwards, which is not necessarily correct. You can only write a proof this way if the steps backwards are valid, and there's no obvious reason for supposing that. You should start at things that you know are true and work down to something that you want to prove. All right. So let's go again here. So let's see. I'm not sure. All right. It looks like. So I think that what's happening here is the person is trying to work backwards. But as I said, you can't, just because you can go forwards doesn't necessarily mean you can go backwards. It's better to always go forwards. All right. If you can go forwards, you might as well go forwards. So the person should have rewritten the proof. And in fact, I think you can go backwards. If you start with this, that's certainly true. Then here you're just substituting A and B. That's certainly true. And then here you're substituting this. You're doing both substitution and proposition 3.4.4. That's true. And then here you can go back to here. So if the person had simply written the steps backwards, this would have been fine. But as it stands, it's just kind of, it's like driving on the wrong way, driving European style in the United States. You're just going on the wrong side of the street. Okay, here's another one. Let's see. So here, see what I'm having trouble here is that again, the person is starting with what you want to prove, right? And then here, so okay, so I'm not sure if they're starting with this or not. I'm not sure if they're asserting this or not. They just put it there. But do you see my quandary? I don't know what this means. If you said this is what we want to prove or something like that, then I know what it means. If I don't, I think it's part of the proof. Okay, so it's causing me a problem. All right, then here we have x mod n plus y mod n equals x plus y mod n. This doesn't mean anything, as I said before. All right, so I'm just going to stop at this point and move on. Okay, well, I think that's enough, but I do hope that seeing me explaining my thought process in grading these proofs will help you write better proofs. So I welcome any feedback. You can email me. Just hope that this does help you prepare for the test.